And welcome to the Organic Chemistry Bond Line Structures tutorial. Bond line structures are a faster way to draw organic compounds. You see, carbon is the most popular atom in organic chemistry, and bond line structures save us time by not having us draw the carbon atoms at all, or the hydrogens that are bonded to the carbon atoms. Bond line structures represent carbon atoms with zigzags. The corners and the endpoints are the carbon atoms. The lines between them represent their bonds, and this is called the zigzag format. Now remember, the bond line structures won't show us the hydrogens bonded to carbon, so it's up to us not to forget that they're actually there. For example, to find out how many hydrogens are bonded to this carbon, we simply remember that carbon likes to form 4 bonds in order to become more stable. This carbon shows that it has formed 2 bonds, so therefore it must be also bonded to 2 hydrogens. In the case of this carbon, it shows it's made 1 bond, so therefore it must be bonded to 3 hydrogens, which makes a total of 4 bonds, which the carbon likes. Now I want to show you how to draw the double and the triple bond in a bond line structure. To draw the double bond, simply place another line between 2 carbons. Notice that this carbon will make 3 bonds when the double bond is added. Therefore, it must be bonded to only 1 hydrogen atom. The triple bond looks like this. These carbon atoms are participating in the triple bond. Notice that the triple bond is drawn in a straight line instead of a zigzag. This is because the triple bond actually has a linear geometry in nature. Also notice that the carbons at the endpoints are each bonded to 3 hydrogen atoms. In contrast, the 2 carbon atoms sharing the triple bond are not bonded to any hydrogen atoms. This is because the triple bond helps them complete 4 bonds, which is the maximum number of bonds a carbon atom can make. It's important to be able to visualize how many hydrogen atoms a carbon is bonded to just by looking at how many bonds it's already made. Next, I want to talk about formal charges. They determine how many bonds a carbon will form. A carbon can either have a positive or negative formal charge. In both cases, the carbon will only form 3 bonds instead of 4. These carbons will each be bonded to 1 hydrogen for a total of 3 bonds. The reason they will only form 3 bonds instead of 4 is different in both cases. With a positive formal charge, the carbon is missing a valence electron, leaving 3 electrons to form bonds with. A negative formal charge will give the carbon an extra valence electron, so the carbon will have a total of 5 valence electrons. 2 will stay together to form a lone pair, and the other 3 will be used to form bonds with. The important thing to remember is that a carbon with a formal charge will only form 3 bonds instead of 4. Next, I want to remind you that carbon atoms are not drawn in bond line structures. But if the compound you're trying to draw contains atoms other than carbon, they must be drawn. And if this atom is bonded to any hydrogens, it must also be drawn. The last thing I want to show you is how we represent the third dimension in bond line structures. Compounds form 3-dimensional structures in nature, so we use a wedge when a bond is pointed towards you and a dash when it's pointed away from you. For example, this compound contains carbons all along the same dimensional plane. This compound has a chlorine in the foreground, and this compound has a carbon in the background. Well, that's all I wanted to say about bond line structures. Thank you very much,